Hi everybody, I'm going to show the integration between Camel K and KEDA autoscalers. This allows Camel K integrations to scale down to zero and up, not only when they are triggered by HTTP calls, like it happens with Knative, but also from other kind of sources. For example, in this demo I'm going to show how to scale down to zero and up from SQS and also from a Kafka instance from our managed services. So let's start with SQS. I've created an integration that is a simple camelot binding, as you see here. So the users that want to create a connection between a SQS queue and, for example, a Telegram sync need to create a standard camelot binding providing the properties of each one of the endpoints. The only difference between a standard camelot binding and auto-scaling one is that you need to provide this annotation that enables the KEDA autoscaler. These other two properties, the polling interval and cooldown period, have been set to 1 in order to speed up the demo, but they are not required. You can just use the default. So let's create this and see what happens. SQS. So I've created the camelot binding, and if I go here and see, for example, which pods are running, you see that a pod is already terminating, and there should be no pod here at the moment. This is because let's look at the namespace. So I've installed Camel globally, Camel K globally in the Camel system namespace, and KEDA in the KEDA namespace globally. And KEDA is already scaled down. If you see the camelot binding, this has been scaled down to 0 replicas automatically by KEDA. So the reason why this happens is because we created a scaled object which is called SQS to Telegram. If you look at it, it contains the information that allows KEDA to connect to SQS to check if there are new messages. So if there are no new messages, so KEDA will scale down the camelot binding to 0. Whenever there are new messages, this will be scaled up. Some other information are present also in a secret called this way. So if you look at the secrets, you see that there is this SQS to Telegram key.0 secret. This has been created by the Camel K operator that instructs KEDA automatically. But how does it work? It works via annotations put into the camelot. So the camelot are enhanced with new annotations that enable tells the system that KEDA can be enabled when you use this as a source for your integration. So this KEDA type indicates the kind of KEDA autoscaler to use, but also the properties. If you see here, for example, the access key in the camelot is mapped to AWS access key IT in the KEDA system. There is also a templating system that allows you to do also complex mapping between properties, but they're not necessary at the moment. So the camelot is created and published into the catalog as other camelots, so that users needs only to enable KEDA via this annotation, and this can be also used done graphically in some way. So let's see how this works. So once I've created this camelot binding, I expect that if I send here a message like hello, I will receive this message in this chat. So let's send this message and see what happens. So let's see. Okay, maybe we can do something better. So let's watch kubectl get pod. Okay, you see that there is a pod that is running, another one that has been created. Sometimes it becomes flaky, and if you look, there is an integration that has been started and stopped, and while it was started, a message has been sent here. So now there are no new integrations running because we don't have new messages, but the integration has been scaled up in order to process the message, and then it has been scaled down. And this the source of this integration was SQS, not an HTTP endpoint like it happens with Knative. Okay, we can do a similar thing here, but not from SQS, but from Kafka. So we see also scaling out to multiple instances. Okay, I've created a broker called Camel K with a topic called messages, and I'm going to create another integration called KEDA to log, so Kafka to log, sorry. This uses the standard property that has KEDA enabled and the usual properties to speed up the integration. This logs just the messages, but I've added also a delay action to just delay the processing by 3 seconds in order to see how everything scales out to multiple instances. So let's create this Kafka to log.yaml. Okay, you see that an integration, an instance has been created, but it is already being terminated by KEDA because it has checked that there are no messages there. So there is nothing running at the moment because we don't have data. Okay, we can send data using this script that I've created, just to send hello to the topic. So send data. Let's just send 5 messages and see what happens. This is are being sent in parallel. Okay, so a single instance here has been created, and it is going to subscribe, and then you see here printing hello 2, hello 3. So there are 3 seconds between each one of the messages just to slow down the processing. Okay, once you receive the 5th message, okay, they are not in order because they are sent also in parallel, so they are sent out of order. Okay, the integration is scaled down to 0, so you don't have to, you don't have any resource that is waiting for a message except for the KEDA operator. So instead of sending 5 messages, let's see what happens if you send 500 messages now. So now messages are being sent, and KEDA has detected that it needs to run a new instance here, and since there are a lot of messages, it has also created other 2 instances. So now the processing is distributed among 3 pods that are running. So the one is running now, but as soon as the others will start to subscribe, they will also show the messages. So this is how it works. After all the messages are going to be processed, then everything will be scaled down to 0 again. So thank you very much for listening.